Hello, everybody. Today we will be presenting our industrial engineering senior project presentation on a fruits and vegetables company in Saudi Arabia named Ghiras. Currently speaking is Abdul Rahman Al Hadban, and later on, my partners will take over. My partners are Faisal Al Mazrou and Abdullah Mumina. Starting off, we have provided the following outline for our presentation. First off, we will introduce you to the company with some background information and explain the scope of our project. Then we will demonstrate the current state of our company using visual aids such as the process flowchart and the fishbone diagram. Next, we take a look at our forecasts for the company's demand, explaining which method we used and why. After that, we will move on to the analysis segment of our project, where we will implement different tools such as MRP and facility layout to solve our main problem of not meeting the daily demand. Finally, we will be concluding the results of our analysis in the summary. So to give you a sort of overview on the company, Ghiras was founded in 2015, which means they're a pretty new company and they are a startup company. And this was one of the main reasons that we decided to do our project on Ghiras, is because startup companies usually have a lot of area of improvement and we figured that there's a lot of areas that we could implement our project on. Although it is a newly founded company, Ghiras is currently one of the top emerging fruit and vegetable companies in Saudi Arabia, and the reason is due to a lack of competitors in the business. They are affiliated with Hassad Development Company, which is a very big investment company in Saudi Arabia, which leads to their ongoing success. Upon working on the project, we ran into some obstacles. The biggest of which was that due to COVID-19, the company had to shut down for some time. Ghiras had to shut down for 12 weeks, which actually affected our data collection process, and it also affected the company greatly. After coming back from the shutdown, we started collecting data from the company accordingly, and then we decided to set our scope, which is to use multiple analysis tools to maximize profit for the packaging and distribution of the fruits and vegetables, and to overall optimize the process. Here you could see our production process flowchart, which actually outlines the whole process from beginning to end. First of all, it starts by unloading the fruits and vegetables that come from the trucks and taking them to our first station, which is called basic washing. In basic washing, the fruits and vegetables are washed simply and then taken to the next station, which is picking. After they are selectively picked, they are taken to the next cleaning station, which involves a more thorough cleaning process that involves water and solution. After these fruits and vegetables are further cleaned, they are taken to the next station, which includes packaging. It actually involves machines that package the fruits and vegetables into the appropriate sizes and weights and labels them with the weight that they have. For this segment of our project, we devised a fishbone diagram to solve our biggest problem, which is failing to meet the daily demand. In order to do that, we had to discover the different areas that could be affecting this problem. We categorized the areas of possible improvement into the following. Each of these categories has different problems that affect our daily demand, but we had to allocate which are the most important areas to implement our work on so that we may meet our goal. The major issues we decided to focus on were decreasing cycle times, eliminating overprocessing, and fixing bottlenecks. The reason we chose to address these problems specifically is that they are responsible for the most time wasted within our process. As we have already seen from our process flow diagram, this is what our current process looks like. It starts with unloading the product from the trucks and moving on to the next station, which involves cleaning and washing. Next off, the fruits and vegetables are carefully handpicked, and then they are sent to the next cleaning station, which involves cleaning with solution. Finally, the product is packaged and then sent to shipping. We actually timed all these processes as shown right here. And these are the seconds for the cycle times for each process. We actually collected these data upon 15 different days. collecting 20 samples each time. After receiving the demand from the previous year, we forecasted the demand for next year using the moving average method. We actually tried various different methods such as regression and the seasonal models, but we decided to go with the moving average method because it gave us the least yield of mean absolute percentage error. This method actually provided us with a mean average percentage error of 18%.
After getting the forecast, we developed the material requirement plan (MRP) for plastic bags used for packaging and cleaning solution used to clean vegetables and fruits. Plastic bags are sold in multiples of 5,000 with a lead time of 1 month, and safety stock and initial inventory are assumed to be zero. Cleaning solution is ordered in multiples of 5 gallons, which is enough to clean 1,000 units. Therefore, lot size was chosen as 1,000, and it has a lead time of 2 months. Safety stock and initial inventory are assumed to be zero. As you can see here in the table, the MRP for vegetables in the next year. And here is also the MRP for fruits for next year using the same lead time, lot size, initial inventory, and safety stock for plastic bags and cleaning solution. Using Lindo, we performed our linear programming to set up an objective function to maximize profit, which is subject to 3 things. First is product demand, second is product cost, third is company budget. To continue the linear programming results, we obtained the optimal pricing for each product and the optimal quantities per unit as seen here in the tables. Also, something to point out is the allowable increase is calculated for each one of the 8 products. The current profit for the company is $289,407. Using our designed LB model, we could possibly increase the profit by 15,375. So as you can see here in the objective function value, and the variables are the 8 products.
Thank you, Faisal. Another method we approached to assist the lots to meet their demand was improving the process. After observing and understanding the process, we saw an opportunity to reduce one of the 7 wastes, which is overprocessing. We combined washing and cleaning as they are similar in process. By combining them, we managed to reduce the total cycle time by almost 23 seconds. Using the forecasting model, we have an annual demand of 499,685 units of fruits and vegetables, which gives labor savings of $41,110 per forecasted demand. Also, by putting cleaning before picking, some products will consume cleaning solution and might turn out defective. One of the major problems that the company has, most of their processes are done manually. We considered automating the picking process as it has the longest cycle time and the lowest output rate. We found a system that has an output rate of 15,600 units per minute, and it could be adjusted to match the other processes. The graph shows a comparison between manual and automated picking. After that, we performed a cost-benefit analysis on implementing the system. For the cost-benefit analysis, we considered the total cost by calculating the annual labor cost for manual picking, which has 4 workers and is equal to $93,600. And for the picking machine, we calculated the cost of the machine with the installation, in addition to the annual maintenance and 1 operator, which adds up to a total of $38,900. By comparing manual picking and automated picking, we found that we would have an annual saving of $54,700 in the first year with the system bought and installed, and a total of $69,200 in the following years. For quality control, we went for a random product to analyze with the attribute to be monitored as the package weight, which is considered as a defect if the weight is below 580 grams or above 720 grams. We collected 10 samples a day over 20 days and constructed a P-chart which shows that the process is in control but has high variation. After seeing that the process has high variation, we investigated possible causes of variation and found out that the scales are not tested for accuracy, as with time they could measure wrong and are not maintained in a good condition. Also, the number of available scales for packaging stations is too low. Some workers also tend to go off experience without using a scale. So we thought of possible solutions such as developing a maintenance and calibration schedule for scale and increasing the number of scale and packaging stations to have a scale for each operator. We performed a facility layout analysis using the distance score analysis. We started by computing the flow between departments as seen in the table in the right corner. Then we calculated the rectilinear distance between stations and calculated the distance score, which came out to 30,988. After that, we calculated the lower bound, which is by having all departments as close as possible to each other, even though it's not possible in real life, and that gave us 19,755. Then we calculated the efficiency of the current layout compared to the optimal layout and found that the current layout distance score is 56.86% over the optimal layout. After knowing it's impossible to implement the layout we just talked about, we developed an alternative layout and calculated the distance between stations, then calculated the distance score, which came out to be 21,207. Then calculated efficiency, which shows that alternative 1 distance score is 7.35% over the optimal layout. So by doing research, we found out that the industrial workers on average work 1.16 hours per day. By using alternative 1, we will be saving 138 hours per worker annually. That gives us an annual labor cost savings of 1,802 per worker. This is our last slide. It's going to summarize the whole project. We're going to begin talking about the cost to implement the project itself. So the cost to implement the process improvement is $14,500 as the cost of the automated picker, and $1,872 as the cost to implement the changes in the facility layout over 2 weekend days. Process improvement gives us an annual saving of $95,810, and the facility layout gives us a $57,686. That's a total of $153,496 annual savings. Also, by implementing the proposed changes of eliminating the washing process and automating picking process and reducing travel distance, by changing the facility layout, that would increase the production output rate significantly, and we would be able to meet the demand. Lastly, before moving to the questions, we would like to thank our advisor, Professor Saif, specifically for assisting us throughout the project, and other professors for teaching us and giving us the tools to make this project. Thank you for listening, and we would be happy to listen to answer any questions you guys have.